Hello, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IVM Europe. This movie is about the Integrated Virtualization Manager, or IVM. IVM allows us to have simple, quick and easy virtualization. It comes as part of the Power VM package. IVM is actually implemented in the VIO server. If we install a VIO server onto a brand new blank machine, it will install IVM function as well. This VIO server will then own the hardware of the machine. It is then willing to host logical partitions that share the CPU. They'll have their own piece of memory, but they will have virtual disks, virtual network, virtual optical devices and a virtual console. In the latest version of IVM, these logical partitions can actually own their own physical adapters. If we compare this to the HMC, the other way of doing virtualization on power systems. The IVM supports the JS12 and 22 blades, all the way up to the 8-way. It gives us the vast majority of the HMC function with a lot less effort, but it only allows one VIO server. To install IVM, we either have to attach a dumb terminal or terminal emulator to an RS-232 line, or for the JS12 and 22 blades we can use the built-in Blade Center screen and keyboard. We then power up the machine by plugging in the power cables, and we get to the ASME menus. Here we should reset to factory defaults. If necessary, we can update to the latest firmware, and then we power on the main system. At the SMS menus, we have to select the installation device, either the DVD or a network install. We install the VIO server 1.5.1 or later, and then we run a couple of commands once it's running. We have 5 further steps to make the IVM website available. We log in as this user called padmin. Next, we accept the license agreement. It's very good to get the time and date correct at this point, so we use the ch-date command to do that. Next, we run the make-gen-config command. Rather an odd command, but amongst other things, it sets up the 4 virtual Ethernets inside the machine. Next, we want to make the virtual IO server and IVM on the network. So we're going to use the make TCP IP command here, as you can see, standard parameters to get a network running. The last two are the DNS server address and the DNS server domain that we need. Once they're done, the IVM website is available. Okay, let's go and find the IVM website. This is the name of the machine, orange_IVM in my domain, and we'll just go there. This is the front page. It wants me to log in as the same user admin. I probably had to change the password when I first logged in, but let me just type that in now. And it's allowed me to log in. A whole lot of information it presented us straight away. Down the left hand side here we have all the menu items of the places we can go. We click on one of these, then this panel over here will change. At the top here we have a summary of our machine. So we have 16 gigabytes of memory and 4 CPUs. It's a Power 6 based machine. It's a 520. We also see that the memory available is just under 14 gigabytes. Here we actually have the first logical partition. It just happens to be the virtual IO server, and it comes out slightly yellow here. We can see that it's been given 0.4 of a CPU. If we look up here, we've got 4 CPUs and there's 3.6 that could be allocated to logical partitions. You see down here that the VIO server running the IVM website is running, as you'd expect. It's actually been up for 22 days. And this is just as you would find it when you first logged in for the first time. We're actually looking at the View and Modify Partitions panel, which is the first item on our menu here. Let's go down this menu now and find out other things about the machine. Next we'll look at the system properties. Here we can find out the name of the machine, which is made of a mixture of the type of the machine and its serial number. We find some status information here, so the LEDs don't show anything on the front of the machine, and we're operating, which is just as well as we're actually looking at the website. Down here it says the absolute maximum number of partitions is 40. This is because we're on a 4-way machine, and as a minimum each logical partition needs 1/10 of a CPU. It's currently defined to have up to 11 logical partitions. If we wanted to go above that, we'd have to change this number and reboot the machine. This number is used to create the virtual resources inside the machine so that we can allocate them to logical partitions. We look at memory, we see a summary of how much memory and how much is used in the machine. The minimum size of memory we can allocate is 64 megabytes. This is by default generated off the size of the memory in the box. And we look at the processing. As we saw before, we have 4 CPUs in the machine, and we have 3.6 available to allocate to logical partitions. Now let's look at the I/O adapter management, the host Ethernet adapter. This is also known as the IVE, the Integrated Virtual Ethernet. This is a special adapter that can do virtualization in the hardware. At the moment it's not in use, but we can see we have 4 links out to the outside world via our HEA, and 2 of these have cables plugged in. This is the link state is up and 2 of them don't. At the moment there are 14 connections on each of these ports available. We could assign any of these to logical partitions. Look at the virtual Ethernets. This is the Ethernets that are running inside the machine. At the moment it is the default setting, and we'll have to make changes in here before we create our first logical partition. These are the 4 internal Ethernets we created when we ran the make gen config command earlier. We can also see that is the VIO server bridging these out to the physical network, and at the moment none of these internal networks are bridged. We'll have to again make a change here before we create a first logical partition. Let's look at our physical adapters next. These are the adapters in the machine that the VIO server can see. A 4 gigabit fiber channel PCI Express adapter in this slot. We've got a 2-port Ethernet adapter. I think we're using this one to actually communicate to the network at the moment. Another fiber channel adapter, a USB, and here we have a SAS adapter. This is actually built into the machine. If we click on the View Children, we can see, if we run down here, this is where the actual disks are that we're using in the virtual I/O server. If we look further down, we find here a DVD-ROM drive, and we also have a 4mm DAT tape inside the machine. Next we'll look at virtual storage. Before we create a logical partition, we need to create some virtual disk for it to use. At the moment there are none. Again, we'll have to do something here before we create a first logical partition. The storage pools is where we allocate space for our logical partitions. At the moment there's the default one, which is the root volume group. This is actually the disk in which we're running the virtual I/O server, and we can see how much space is available to it. If we look at physical volumes, we can see how we're using those. At the moment we have 5 disks here that we haven't actually started using yet. It would be a good idea that we put the virtual disks for our logical partitions on separate disks to the one that we're actually using, the VIO server. This will make backing up our system a lot easier. We also have virtual optical devices. We have a real optical device. It's not assigned to any particular logical partition at the moment, but we could do, and then we could boot off it. If this was a DVD-RAM drive, we could actually then do backups to it as well from our logical partitions. We can also create a optical library of ISO images, and we could mount these into our logical partitions, and they would behave exactly like a DVD drive. So we could, for example, install our operating system from it. There's a few things then for managing the IVM itself. We can create users. Here's our padmin, the default user, but we could create more users with different permissions, perhaps a read-only user that we could trust to anybody. They could have a look around the machine without actually changing things. Here's the IVM TCP IP settings. We set these earlier with the make TCP IP command. Here's our name and our IP address. We're using this one here, the EN0, on our 2-port Ethernet adapter. We have our DNS settings, and we have our default route. We can change all these here from the graphical user interface, this website. Of course, we do have to be careful. We might actually drop off the network if we get something wrong. We also have some guided setups. This will give us some hand-holding if we wanted to do particular operations on the machine, and give us more information of how to actually do that. Also, if we want to upgrade our Power VM attributes, for example, if you wanted to update from Power VM Express, the default version, up to the Power VM Enterprise version, where we have lots of logical partitions available, and we can do things like partition mobility, then we would put the activation key in here that we get when we purchase this feature, and then we can apply it and get that available to the system immediately. We also have something here called a system plan, which we could use to actually set up all our logical partitions. It's very good to actually create a system plan and we've changed things on the machine, because then we can clearly document exactly our setup that can be useful for disaster recovery. Down here below we have a number of things. The service focal point is monitoring the system for events, and we can set this up so that it would phone up IBM to give details of any problems we have, so that IBM can send an engineer with the right parts to correct any problems. We also can do updates to the VIO server and run backups here, both create and restore backups of our client partitions. We have a series of logs of what's going on the machine, so we can have a look at what's been happening recently. We can monitor things that we've changed, and we have a hardware inventory, which is a good reminder of everything we have in the machine.